Hello, Mishler Math Geometry students. Today we're going to do a lesson on GeoGebra, and I'm going to do some magic tricks first. I'm going to make Polygon 1 appear. What kind of a polygon is that? If you said pentagon, good for you. Watch what happens when I label the points here. Okay, now what am I going to call this pentagon? Can I call it Pentagon A? I don't think so. Let me show you the names. These are all the possible names for this polygon. I can call it ABCDE, BCDEA, CDEAB, DEABC, or EABCD. Now, some of you might have figured out a pattern here, but let's look at the other names that I can call this polygon. Or I can call it EDCBA, DCBAE, CBAED, BAEDC, or AEDCB. Now, have you noticed any kind of pattern there that is used to name this polygon? If you have, good for you. I'm going to ask you a question in the video. Embed the question, and we'll see if you can figure this out. And now we're going to look at something else. We're going to talk about polygon congruence. For example, suppose I had this other polygon sitting up here. I say, okay, this is PQRST or QRSTP or RSTPQ or, and you get the picture. Now I want to know if this polygon is congruent to ABCDE. It looks like it might be, right? So let's see. Watch what happens when I do this. I'm going to take this thing and I'm going to move it over here and I'm going to put it on top of this. Now you notice that this thing lines up pretty much perfectly on top of the other polygon. Okay? And what that means is that all of the sides and all of the angles for both polygons are congruent. And we say that point A lines up with point P, B lines up with Q, etc. And so we make what we call a congruence statement. Okay? We can say ABCDE, that's this one. Sorry, I moved them around a little bit. We can say ABCDE is congruent to PQRST, or we can say PQRST is congruent to ABCDE. Now, we can make that statement 10 different ways or 5 different ways depending on how we name the polygon. In fact, there's a lot more opportunity or possibilities than that. The point is there are 10 different ways of naming each polygon. So we don't have to worry about all that. The point is we want to get to is that you have to name the polygon. Look at when I write this congruence statement, look at point A and point P. Point A and point P are the first letters in naming both of these polygons. If I said that ABCDE was congruent to QRSTP, that would not be a congruence statement because that would mean AB is congruent to QR. And AB is not congruent to QR. You understand what I'm talking about here? So when I say BCDEA is congruent to QRSTP, then I look at B, that's my first letter, B, C, D, E, A. And then I look at this one, it says Q, QRSTP. So I've got to do these things in order. Now, once again, just so you're clear on this, a congruent statement means I say this is congruent to the other thing. That's all it says. This polygon is congruent to that polygon. That's what we mean when we say congruence statement. When I write a congruent statement, I have to use the congruent sign that shows up here. And I have to put them in order. Okay? So let's try one, shall we? Let's try a new one here. And I'm going to save this one. And I'm going to try a new one here. I'm going to make a triangle. Let's say triangle A, B, C, and A. And I'm going to move this over here so we can see that clearly. And now I'm going to try another triangle. Now, you think these two triangles are congruent? I don't know. Let's see. Can I pick this triangle up and put it over top of this triangle? I think even if I tilt this thing, I don't think I'm going to be able to do that, am I? I don't think so. So, because if you look, say I wanted to say ABC is congruent to EDF. Well, if I look at this, even if I put this, twist this thing around so ED is lines up with AB, so in other words, this side lines up with this side, even if I were to do that, I don't think that that would work, do you? No, I don't think so, because I think this triangle is a lot bigger than that triangle, so they don't look congruent to me. So let's try something else. Let's get rid of this triangle, and let's try something else. I'm going to try to copy, and, oops, paste. And you think these two triangles are congruent? Well, I can find out real quick. All I have to do is put this triangle on top of that triangle, and it looks like they're congruent. Now the trick is, how do I write a congruent statement? Well, I say triangle. I wonder if I have a symbol for triangle in here. Ooh, it looks like I might just have that. There we go. Triangle ABC is congruent to triangle A1, B1, C1. And there's my congruent statement. And I can make this bigger if I want. I just go to Object Properties, Text, very large and bold and OK. I can make this even red if I want. And there we go. So triangle ABC is congruent to triangle A1, B1, C1. That's my congruent statement. Now, what if I made a different congruent statement? Let's suppose I wanted to say triangle ABC is congruent to triangle B1, C1, A1. You say, well, that would be correct because B1, C1, A1, that's just another way of naming the same triangle, right? And hang in there a minute. Let me make this Object Properties, Text, large, bold, and color green. You say, well, why wouldn't this work? Because after all, B1, you told us B1, C1, and A1 would be a proper name for this triangle. It would be a proper name for this triangle. However, this is very important. I have to have it in the same order. AB has to correspond with A1, B1. So if I call this triangle B1, C1, A1, then I have to call this triangle BCA. And so if I were to call this triangle right here triangle BCA, then I would have a correct congruent statement, and I'm going to make this extra large just to show that yes, I do have a correct congruent statement. Okay? So these are two ways to make a congruent statement about these triangles. ABC, triangle ABC is congruent to triangle A1, B1, C1, or triangle BCA is congruent to triangle B1, C1, A1. Understand how that works now? I certainly hope so. You know what the saying says, there will be a test. Thanks for listening.